Intermediate Algebra, Section 9.3. We're now ready to study inverses of exponential functions. These functions have many applications and are called logarithm or logarithmic functions. For any exponential function, f of x is equal to a to the x power. The inverse is called a logarithmic function base a. And the meaning of log base a is the following. For x greater than 0 and a positive constant other than 1, that being the base, log base a of x is the exponent which a must be raised in order to get x. Thus, when you have log base a of x equal to m, we can think of this as the exponent a to the m is equal to x. In other words, the logarithm base a of a number x is the exponent to which a must be raised in order to get a. Or equivalently, log base a of x is that unique exponent for which a raised to that logarithmic power is equal to x. Let's put that meaning of log into use and see if we can simplify the following. So we're going to set this equal to an unknown value, and we're going to translate from the logarithmic form into the equivalent exponential form that we wrote down just a minute ago, which was if you have log base a of x is equal to m, it's equivalent to a to the m is equal to x. So here we have our logarithmic form. We will take our base here and use it as our base when we translate it into the exponential form, raised to the m power, so it's equal to this unknown, is equal to 1/100th. And 1/100th, I'm going to write, instead of as the decimal, I'm going to write it as the fraction equivalence. The goal is to get a common base. Well, 100 is 10 to the second power, and to have it as a base 10 out of the denominator, we would write this as 10 to the negative 2. If we have common bases equal to one another, it means the exponents must equal one another, and that's telling us that x has a value of negative 2. So log base 10 of 1/10 is equal to negative 2. Let's take a look at this next problem. Same thing again, translate this from logarithmic into an equivalent exponential. Our base is 25 raised to what power? Our unknown is equal to 1. Well, there's only one value that we can raise a base to that gives us 1, and that is when we have an exponent of 0. 25 to the 0 power is equal to 1. That's telling us that x is equal to 0. In the next problem, we have log base 7 of 343. We'll set it equal to our unknown. We'll translate it from logarithmic to the equivalent exponential form. So 7 to what power is equal to 343. And it's a good guess that 7 is a factor of 343. And as it turns out, 343 is equivalent to 7 to the third power. We have common bases equal to one another. That means our exponents are equal. And so x is equal to 3 for the solution to this logarithmic problem. In the next example, we'll do the same thing. We'll translate this to an equivalent exponential form. So our base of 5 raised to what power is equal to 1/125. And you hopefully are seeing a pattern where we need a common base. And instead of writing 1/125, I'm going to factor 125. 5 to the third power is equivalent to 125. To get a common base, we will write 5 to the negative 3 power when we bring it to the numerator, and that leaves us with common bases. Our exponents are equal. So log base 5 of 125 has a value of negative 3. So our unknown value is negative 3. In this next example, we're taking log base 4 of 4 to the 5th power, translating it into an equivalent exponential form. We have 4 to the unknown power is equal to what we're taking the log, and there's no work needed as far as getting a common base. We already have our common base. Since they're equal, exponential powers have to equal one another, and our solution to this logarithmic problem is 5. In this next problem, we have a translation for this already as part of the meaning of log of x. If you look here, we have our base raised to the log of the same base of a quantity equals that quantity. And if you notice, we have that pattern here in the problem. 3 log base 3 15 is equal to 15. But if that doesn't work, or you're not seeing that, this is essentially exponential forms. A base raised to a power, even though the power is rather awkward looking, is equal to something. We could put this in an equivalent logarithmic form. So we're going to go from exponential to prove this into an equivalent logarithmic form. So that would be log of this base, this is our a, of x is equal to the exponential power. And our exponential power, that whole exponent, is the expression log base 3 of 15. So having written this in our logarithmic form and comparing this, we have log base, and I wrote a, which it's actually should be a 3 here. We have the same bases on our logs. Their log of x, we don't know, is equal to log base 3 of what? Since the bases are the same, we're taking log of the same number. X must equal 15. So we got the solution by translating our exponential form into logarithmic form, just the opposite of what we've been doing on the previous ones, or could have used that definition from the meaning of log base a of x.